Hey guys, so today we're going to talk about 10.7, which is areas of circles and sectors. The notes are going to be very similar to yesterday's notes, which was circumference and arc length. So let's just talk about how do you find the area of a circle. There's only one formula. Area equals pi times radius squared. So let's use that and just go through some examples. So for example 1, we're going to find the area of the circle, and we're going to leave it in terms of pi. So look at what you've been given. We've been given that the radius is 5.2 inches. So we're just going to plug that into our equation. So when you guys are leaving in terms of pi, you are definitely going to square 5.2, which gives you about 27.04. And then we typically see the number in front of pi. And we've been given inches as our units, so we'll say inches squared. All right, let's take a look at example 2. So example 2 is the same idea, but this time we're going to find the radius of the circle. So if you look at the very bottom here, we've been given the area of the circle. So let's plug in what we know into the area formula. So we know A is 201 feet squared. I'm going to drop down pi, drop down radius squared. That's what I'm looking for. Feel free to call it X. So we are going to solve for R. So if you want to solve for R, the pi and R squared are being multiplied. So to get R by itself, we're going to divide both sides by pi. For now, I'll just leave it as 201 over pi equals R squared. And then how do you just get R? Well, you're going to square root it. It doesn't tell us how to write our answer. I'm okay if you leave it as the square root of 201 divided by pi. Or you can actually type that into your calculator. If you type it into your calculator, make sure you do square root, and then in parentheses, do 201 divided by pi. You can also just use 3.14, and then just close the parentheses and then hit enter. So when you do that, let's see what we get. I'm going to use 3.14 because I don't actually have a pi button on the calculator that I'm currently using. You end up getting about 8.0. So 8 is your radius, and we were technically given feet, so it would be 8 feet. Okay, here's a very common area problem. We're trying to find the area of the shaded region, and we're going to leave our answer in terms of pi. So we kind of have like a donut. We have a donut, and we're trying to find the area of just the donut. So in order to figure this out, you actually have two circles. You have the larger circle on the outside, so I'll just call it, you have the big circle. And you have the small circle on the inside. That's what makes a donut. So let's talk about finding the area of the big circle, finding the area of the small circle, and then if I just want to know the shaded part between them, I'm going to subtract the areas, because I'm basically taking out the area of the small circle from the big circle. That's how you get the donut. Okay, so let's look at the big circle. So I'm just going to circle it here in red. So I just need to know the total radius.
Ms. Almer, please call the main office at 500,002. Ms. Almer, please call the main office at 500,002. Thank you.
I just need the total radius of the big circle. So the total radius is 4. And since it says leave it in terms of pi, Just square the 4, you get 16, and just put the pi next to it. All right, so that is my area for the big circle. Now let's do the same thing. I just need the radius for the small circle. So if I look at the small circle here, my radius is just 2. Again, just square the 2. You get 4 pi. Now we're going to subtract these answers. Kind of think of them as like terms, like 16x minus 4x. Instead of x, we're just using pi. So 16 minus 4 is 12. Pi tags along. And we are given inches as our units. And anytime you're doing area, your inches are going to be squared. All right, let's do one more that's kind of similar to this. So again, we're finding the area of the shaded region. Anytime you guys are doing shaded region problems, there's always going to be 2 shapes. So what 2 shapes are here? Well, I definitely see a square because this side's 10, this side's also 10. So, and this is a 90-degree angle. So we have a square and we have a circle. So we're going to find the area of both of those shapes. And then we're going to do exactly what we did before. If you're ever trying to find the shaded part between them, you're going to end up subtracting them. So how do you guys find area of a square? Well, that's just base times height or length times width, you know, however you learned it. I'll just label it length and width. So the length and the width of the square are just 10 and 10. So this is just 100. All right, and then let's take a look at the circle. So we're going to do pi times radius squared. So again, just for the circle, you need to know the radius. So I know there's no center drawn, but if I were to draw a center and just go halfway, what is that length? It's going to be 5, because the total length down here of the square is 10. So if I were to chop it in half, it's going to be 5. Okay, so let's go ahead and square that 5. So you're going to get 25 pi. And we're just going to subtract our areas. It does say leave in terms of pi. So again, think of these as like terms. Like if I were to give you 100 minus 25x, are you guys able to join those to make like 75x? No, you're not able to, because one's just a number and one has an x to it. So since my area of the circle has pi next to it, I'm not going to actually combine these. I'm just going to write them next to each other. The area of the shaded region is just 100 minus 25 pi, and centimeters were our units. So just make sure it says centimeters squared. All right. So now we're going to move on to sectors. So you might be thinking, okay, what is a sector? So here I have 3 different pictures of sectors. Sectors are really just slices. Okay. Think of them as like pizza slices or pie slices, okay? They're just parts of the circle, and they're typically shaded so you know like what slice you're looking at. So we just give it 3 names, or I'm sorry, 3 letters for the name. We just use the 3 letters that make up the angle of the slice. So this would be sector, you know, RPS, this one's ABC, and this one over here is DEF, which is just half a circle. So let's say I want to find area of these slices. It's similar to what you guys were doing yesterday and also what you were working on today in class. So let me draw a slice. So draw this with me. Let's say I want to find the area of this slice of my circle. Well, in order to do that, I need to see what fraction of the circle is this slice taking up. And then since I'm finding area, I'm going to multiply that fraction to the area of the circle. So area of a sector is really just the fraction of the circle's area. So we're going to pretty much use the same steps you guys were working on earlier. To figure out the fraction of the circle, you're going to take arc measure. So I'm going to say area of sector, AS, equals the arc measure of that slice over 360, and I'm going to times it by the area of the circle. So the area is pi radius squared. That's how you find area of a circle. And I'm going to have you, if you have a highlighter, highlight that, because this is what we're going to use for the rest of today's lesson. So let's go ahead and do some examples just using this formula. Okay, example 1. We're going to find the area of the shaded sector, and we're going to leave our answers in terms of pi. So let me just jot down the formula. So area of the sector equals arc measure over 360 times area of a circle, which is pi r squared. And now let's fill in what we know. Okay, I'm looking at my slice here, sector ABC. The measure of the arc is going to be the same as the central angle, it's 110. So I'm going to plug in 110 over 360. And now we just need the radius of the circle, which is given to us. It's 21 millimeters. So times that by pi, 21 squared. And what I would do first is simplify 110 over 16. So think about what you could take out of it. You could take out a 2. You could take out a 4. Okay, you can actually take out a 10. So when you simplify it, it will become 11 over 36. And then I would also square the 21. So kind of do 2 steps to 1 here. So 21 squared is 441. And I'm actually going to put that first in front of pi. And it's the same thing we've been practicing with arc length. To combine these two, put this over 1, just go straight across, and then see if you can simplify your final answer. So area of the sector will be 11 times 441, which is 4851 pi over 36 times 1 is just 36. See if you can reduce 4851 over 36. You could take out a 3. So if you take out a 3, let's see what you're left with. 1617 pi over 12. Let's see if you could take out another 3. You can actually take out another 3. So if you take out another 3, you're going to end up getting 539 pi over 4.
Cynthia Polite, please report to the
that's
food court. Cynthia Polite, please report to the food court. Thank you.
You can't reduce 539 over 4 anymore because 4 is an even number, 539 is an odd number. And our units originally were millimeters, so just make sure the area is millimeters squared. Okay, try example 2 on your own, or just follow along. So we're going to find the area of the shaded sector. So I'm just going to rewrite the formula. Area of the sector equals arc measure over 360 times area of the circle, which is pi radius squared. Okay. So when I look at my shaded sector, ACB, it's a 90-degree central angle, which means my arc measure will be 90. And we are given the radius is 6. So let's reduce 90 over 360. you can actually take out a 90. So that will reduce down to 1 over 4. And then I would square the 6, which is 36. Put it in front of the pi. And then just stick this over 1 and go straight across and just see if you can simplify. So 1 times 36 pi is 36 pi. 4 over 1 is just 4. Or 4 times 1 is just 4. So 36 divided by 4, that's actually a nice full number, 9. And then pi just tags along, and we were given centimeters. And since we're doing area, our answer is centimeters squared. All right, let's do a few more. So example 3, this one's a little different because it says find the area of circle H, not the area of the sector. I want the area of the whole circle. And we're going to leave our answers in terms of pi. So if you look at what's been given, we have the arc measure, which is going to be the same as the central angle. And we've been given area of the shaded part. So area of the sector. It's not the area of the whole circle because that's what we're trying to find. So we're still going to use area of sector equals arc measure over 360 times pi radius squared. We're just going to use it a little differently. We know the area of the sector. So this is 123.45. We know the arc measure is 70. And this is what I'm looking for. So I'm just going to replace this all with A. I'm looking for the area of the circle. I don't need to put pi radius here. I'm looking for A. Okay, so let's just do what we've been doing. Let's put A over 1, combine those two on the right-hand side. So this is just 70 times A over 360. And you guys can practice this. If I'm just trying to solve for A, I can put a 1 on the left-hand side and then just cross multiply. So let's see, you got 1 times 70A, which is just 70A. 123.45 times 360. Let's see what that gives us. That's 44,442. And then to solve for A, we're just going to divide by 70. It does say leave in terms of pi, but I'm going to change this. Let's just round it to the nearest 10. So this is going to be 634.9. And our units were meters squared. So that is the area of the circle, 634.9 meters squared. All right, let's look at example 4. Same idea. We're going to find the area of the circle S. So feel free to try this one on your own or just follow along. So we've been given this central angle. So that's going to be the same for the arc measure degree. We're also given area of the shaded sector. So let's go ahead and plug in everything that we know into our formula. All right, so for area of the shaded sector, that is 39.52. The arc measure will be 175. Stick this over 360. And again, I'm just going to replace all this with A. We're looking for the area. Okay, what do we do from here? Put a 1 under A, go straight across. So 39.52 will equal 175A over 360. If I want to solve for A, we're just going to end up cross multiplying by putting a 1 underneath the 39.52. Okay, so you're going to get 175A equals whatever 39.52 times 360 is, which will be 14227.2, and we're going to divide by 175. And again, I'm not going to have you leave your answer in terms of pi. We're going to have it be a decimal. Let's do 81.3, and our units were inches, so we'll just say inches squared. Okay, let's take a look at the next one. Oh, that's it. That's all we got. Okay, so let me know if you guys have any questions. Feel free to text me, and have a good night.